in the air and say enough's enough. Do you want to learn to code and make some awesome stuff? Learn that anyone can when you're coding with Dan on
Coding Train, good morning.
Whether you're a pro or this is all brand new, learn the overarching concepts and some fun stuff too. And with Dan as your guide, come along for the ride on
80,912. Oh, hi, Coding Train. Oh, shoot, I pressed the wrong button. My joke didn't work. I'll try it the next time.
Make a crazy pixel mirror to reflect your face. You can make a jump to light speed into outer space. You can generate a maze that can go on for days. You can make your own terrain and some purple rain. You can make a retro game to see how it's done, and then tweak a piece to make it yours for everyone. Make some fractally trees or Twitter bots if you please. And when the seeds are sown, you can make them your own.
53,186. Oh, Coding Train, right.
Ride the colors of code, you can follow the road to
Coding Train, good morning. I know there's an echo. I'm going to be able to get rid of that. I think I have gotten rid of the voice echo. Good morning. That was my attempt of kind of getting that theme song back in there. Please let me know if I'm coming through loud and clear through the interweb waves of air, radio frequency tube things. My name is Dan. I'm playing that song and intro video as a reminder that the new official Coding Train theme song will be coming soon with a new video, and that's the old one when I had a different name. The good times, happy memories. So what is this thing that you're watching? This is a live stream. Yesterday I had a live stream. I brought new meaning to the word live stream actually, but today is a new day, a new frontier. It's going to be, I'm here on the internet. My name is Dan, and I do this every week, typically on Friday mornings my time, which is New York City Eastern Time, around 10:30 a.m., although it appears to be almost 11 a.m., which is usually about when I get started. And what I do is I talk about, and I even have this up here. This wasn't supposed to be up yet. I talk about and present and attempt various things related to computer programming and code. So that's what's happening here. So I'm like almost somewhat prepared, if you could believe that, in that I have an agenda. It's in a Google Doc, which was up a second ago. I also, something really amazing has happened that's going to change my life on these live streams. This is a box of tissues. Coding Train, brought to you by tissues. When your nose is running, you can use one to blow your nose into it and wipe your nose. And then you will not find yourself throughout your entire tutorial scratching your nose and then having lots of YouTube comments saying, why do you keep scratching your nose? And then you start to feel neurotic about it, and it feeds back into your head. And anyway, so there you go. That's a game changer for me here on this YouTube live stream. Okay, hello Switzerland, hello Denmark. I'm seeing people in the chat, and I am seeing the request that I get every week for a room tour and studio setup, please. So I will do that today. Later today. I often do a bonus live stream Friday evening my time because I never get through everything in the morning. I come back and try to do some more. I don't know if I'll be able to do that today, but what I will do is use the time that I often do that to do a studio walk through. Okay. So let's move on to the agenda. Where is it? Here it is. I need another button that I can press that goes da-da, because I'm obsessed with sound effects. You don't like my sound effects, then I challenge you, internet, give me some better ones, or just tell me to stop. Okay, so this is what I'm looking at today. Let me actually skip this stuff for right now and go over some announcements. Okay, so 2 announcements about how things work with some of my GitHub repositories. Number 1 is if you would like to suggest topics for me to consider and approach and cover on in a future session, you can do so here at this GitHub repository under the Coding Train organization, rainbow-topics. Really though, I should probably change this to some kind of like train thing where these are all train stations and they're at certain times and there's a schedule and then the train pulls into the station and then this topic is explored. But anyway. And so several viewers have been helping me organize and keep track of all of these. And there's some, I want to thank Me I Am So Me and actually I don't know how to pronounce this name, the username Callum in the Patreon group. And so you can see that there are some new tags. And what I'm going to do is I'm actually going to go here and do sort by thumbs up. And we'll see now some of these topics. And also I should point out that when I cover a topic then, the issue gets closed. This is one that I did, this is a coding challenge that I did maybe last week, I think. And then I post a link to the video. So you can track this repository, put your suggestions there. And I'm thinking about other ways of, I've had some great suggestions of other ways to maybe visualize this or upvoting techniques, so that's coming. So that repository is there. The camera went off. It wouldn't be the coding train without a camera that shuts off after 30 minutes. Like I could resolve this problem probably, but it's just it's part of the way that we code. We spend 30 minutes and then all of a sudden the camera's off. Then everybody in the chat says camera's off, and then I go and I turn the camera back on. Okay, so that's actually probably less interesting of an announcement. It's not really an announcement, it's more of a reminder that there is also this repository, Rainbow Code, and this is what I'm more excited to show you. So this is the repository where I keep all the example code that mirrors exactly what I do in the videos. Now, there's a bit of an issue with this in that sometimes I will produce code in a video that has bugs in it or mistakes in it or kind of terrible ideas in it. For the most part, I try to have the code in this repository mirror what I do in the live stream exactly, so that if you have an improvement idea, you can actually just, you can use the code that's exactly even with the mistakes and kind of fix them as an exercise even yourself. But sometimes sometimes the code in here, if it's like really broken, I will change it. But more of the issue at play here is that I'm getting so many on Twitter, over email, so many wonderful variations on the coding challenges. And I'm trying to figure out a good way to compile those and let people share them. And I was getting them as pull requests. And so it doesn't really make sense for me to take somebody's beautiful visual idea that builds on top of an example that I've made and alter the example code. So what I've done here, I'm going to go under challenges, and I know a challenge that has a particular, I'm going to go to coding challenge 59 steering paths. So I would pull this up if I had thought about it. But, I'm really like standing in front of stuff today. So this is a coding challenge, if you recall, that made text with little particles moving around, and it wrote the particles wrote the word train. I would show it to you. Now, each coding challenge will have in the directory with the example code a README file. The nice thing about GitHub is if you ever name a file called readme.md as a markdown file, it will actually just appear on it. It will be rendered, the markdown will be rendered on that actual page. So now what I'm doing is on that page you can see community variations. And these are submitted by people pull requesting. So I don't know if I'm not logged in right now. So I would kind of go through how to do this. But I'm sorry, I'm looking at the chat. Stop talking, show us code. Oh, you must not have watched this before because I spend a lot of time just talking. You come back in like 15 or 20 minutes, I'll start doing some code. But I'm gonna, if you're wondering how to do a pull request, send me a tweet. I'm glad to sort of help walk you through that if you've made something and want a pull request. But I also have some, you might be surprised to know that I have some GitHub tutorial videos that you could watch. Okay. Now, so let's look at some of these. So let's look at changes to make the vehicles flow between multiple words. So this is a version that it says hi. So this looks like almost exactly what I did in the coding challenge, where a lot of particles, they have a home base, a target location. They move that are along the paths of a letter form, and then they flee. They use a fleeing behavior to move away from the mouse, and then come back as the mouse moves away. So now, what happens if I press it? It says press the spacebar. Ooh, look at that. There, press the spacebar again. And also let's try clicking the mouse. Ooh, clicking the mouse looks like it makes it go to a random location. And then pressing the spacebar. And so interestingly, you'll notice there has 5 characters, whereas hi only has 2 characters. Look what happens to all the other particles. They kind of go down to the bottom. So that's an interesting solution. Another solution, especially if the text were something that a user typed in, is that you might think about just looking at, okay, I have a certain number of particles right now. Now I get new text. Let me calculate how many particles I need for that. If it's more than the number I have, add the difference. If it's less, then delete the difference. Then set all the remaining particles to a new location. Okay, so that's great to see. Let's look at Joseph Kuchar's changes to make, oh, I love this one, to make the vehicles visible as polygons. This is and actually this is super, but there is a version I can look at. This is incredibly relevant to a coding challenge I want to do today, which is, look at this. This is the same idea, but instead of the letter forms being made up of circles, particles, white things, these are actually now polygons that are triangles. Actually looks like triangle strips in a way, that the geometry is made up by a lot of triangles. And this is something I actually want to cover later, is how to build geometry out of triangles, complex geometry out of triangle pieces, and then how to texture those from an image. So we'll look at that later today. And let's see, what else do I got here? Gawaf's variant, word morphing, and rainbow colors. Ooh, look at this. So this is great. So this, there's a different font. There's some rainbow colors, and now I can also put the text in, like, hello, YouTube. And there we go. Oh, and look at this. Let me just delete the E. Whoa, look at this. Wow, that is really cool. I love this. So great. And then I can change the dot size, and I can change the resolution. So can we really see this, though, with that? So resolution. Oh, that makes it even more. I want to make it like less. Yeah, so you can see that resolution variable is a variable that kind of how many dots per spot along the path. And with 0.01, you can barely see the text. But with 0.1, you can see it more. Oh, this is wonderful. Wonderful work. Okay, so that's the other thing I want to mention. So if you're doing stuff and you want to share it in a place that people can find it, share it with me. This is a system for doing that now. Now, at some point, it might be nice to have an even more elaborate system, but boy, this mug, it's the invisible mug. What is in this invisible mug? You can all try to guess today. Okay, so that's what I've got to say. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot. All right, just got to get the body moving here to get some energy going. Okay, what else do I have to talk about? So I talked about these two things. Aha, store coming soon. I have had requests for coding train related merchandise. So this is a t-shirt sample that I received, and there's a bunch of variations of that, and some mugs, maybe some other things eventually too. So for those of you who are interested, I will be sending out a link to a store where you can buy this sort of stuff. If you are European, or not just European, but not from the United States, the system that I'm using currently is the shipping is a little bit expensive to outside the United States. So I'm working on also an alternative for people who are maybe not in the United States. So, but if you have ideas, the reason I mentioned European is just because I noticed it was particularly expensive to some European countries. So if you, and I'm also thinking like, maybe I can use these for prizes and that type of thing at some point if I do some type of. So if you have ideas for that, I'd love to give some of those things away as a thank you to this wonderful, warm, and friendly and supportive audience who somehow tunes into this. Okay. All right. So that's another announcement I have. Aha. Okay. Now, for all of you who have been asking me to do some tutorials that relate to machine learning, the time has come. I work at this place called NYU, and I am currently teaching a class about simulation of natural systems in motion and animation code stuff based on the Nature of Code book that I've talked about probably a number of times. But I am doing that. The course restarts again about 2 weeks from now. So I'm going to go to github.com/Schiffman. I'm going to show you two things. Number one, repositories. I'm looking for this. So I have been working on a list of topics for a syllabus that's going to happen in the second half. And part of the way that I do this is I kind of spend all week working on stuff here at NYU, and then on Fridays I come and make videos about stuff that I was working on during the week. So this is coming. If we look at the syllabus, this is my current plan. Week 1, I want to kind of just get started with kind of thinking about algorithms and efficiency, and maybe look at some kind of common almost computer science programming problems as a kind of, I'm not sure if I'm going to actually do this the first week, but this is what I'm thinking of. Then I want to kind of ease into the topic of machine learning by looking at some classic algorithms for doing 2 tasks that machine learning algorithms are particularly well suited to do. One is classification. So hey, here's an image of a cat, here's an image of a dog. Or actually more like, here's 100 images of a cat. Now here's 100 images of a dog, and maybe more like 1 million images of a cat, or 100 million images of a cat would be better. And then now here's a new image. Which one do you think it is? That's classification. And then regression, which is a technique similar to classification, but more about predicting. It can be, these are broad topics, but I want to look at the idea of regression as a prediction. So instead of classifying it's either A or B, here's a set of properties. Could I predict what what the price of a house is going to be based on a set of inputs, that type of thing? These kind of classic, or predict a stock price if I look at a time series. So after that, actually, I think I want to do this in another order. I'm going to look at genetic algorithms, which I've actually done a whole video series about already. So this is one topic that I've actually done stuff about. But I want to add to the genetic algorithms examples, in particular by looking at evolving steering agents. So vehicles, agents, particles, voids, things that like move around the screen based on a set of rules. How can we give them a virtual DNA and evolve them? So that's a week that I'll do some videos about. Then I want to look at neural networks in some ways from scratch. Like, what are the basic mechanics of them? A simple perceptron, which is the simplest neural network. I want to look at, what can it do? What can it not do? What happens if instead of we have this sort of like single neuron that has some inputs and an output? What if we add a bunch of them together? And kind of look at the mechanics of it and do some simple demonstrations. But then ultimately the idea is, once I get through that, what I would like to do is move to using so to get sort of like a foundation of understanding of how these things work. But we're, there's not realistic to implement super sophisticated neural network systems that you can train and do all sorts of stuff with that are already implemented and done in kind of a lot of open source libraries and tools. So I might look at using something like TensorFlow or other. I'm happy to take your suggestions of other frameworks for doing machine learning that we can make some simple examples. Reinforcement learning is something I want to take a really big look at. There's a wonderful example that was just here. Oh, shoot. This is a problem with using a computer in these live streams that doesn't steering. Wait, I know. I'm just going to Google this. Driving car in the browser. Jan Huberman, I'm not sure I'm not saying the name correctly, recently came out with. It's like actually on the. Here we go. This is a wonderful demonstration of this. So this looks a lot like some of my examples. in that there's a steering agent moving around the space. And we could design a system built on top of Craig Reynolds steering behaviors, that I've gone through: seek, arrive, path following, flow field following. And Reynolds has a behavior that's obstacle avoidance, which is very much a top-down. This is how you avoid obstacles. Let me give the instructions to the vehicle. As opposed to a vehicle that's moving around the space, it just sort of knows, it's able to just see, is an obstacle in front or behind or to the left and the right, and it's going to make a guess on what to do next, and it's going to get some reinforcements. Like, here's a little piece of cheese, vehicle, if you do a good job. But if you don't do a good job, like bzz, a little electric shock. So reinforcement learning, kind of reward-based system that over time, an autonomous agent could learn how to. And Universe is an open source system that uses reinforcement learning to train an agent or a bot to play a video game. So these are some things that I want to look at. Okay, thanks for the talk. Code now. It's coming. Don't watch just watch the released videos if you just want the code part. That's my suggestion to you. I don't know, maybe I shouldn't talk so much. What else am I supposed to do? Oh, dance. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I need some new music. This dot, this dot, this dot. I'm going to do this dot, this dot. Oh, I should play the kitten song. Unicorns and okay, where am I? What else is there? Yes, kittens. Thank you very much. Kittens and rainbows. Okay. So then I also want to look at certain kinds of so-called deep learning systems that are recent research to work with images and text, convolution, and recurrent neural networks. If only I had the graph of the live audience. I should really put that up. I should have almost like I've got I'm a QVC salesperson or something with that live graph of whether people are calling in to buy the product or not. I don't know what I'm talking about. I should have that. The YouTube viewers are all dropping off now. Okay, so that's coming. Any suggestions, ideas, thoughts about this? File an issue on this repository. Send me a tweet. I'm looking for examples. I'm looking for ways to do this in a simple, accessible way that you can pull and also work with tools like creative coding tools like processing in P5. Okay, the other thing I'll just mention though, related to this, and I've had so much help with this that I would be remiss not to mention it, is under Coding Train organization, there is also a machine learning repo that is just, somebody made, this is quite nice, thank you, that has a lot of different resources and things that I have been compiling. And honestly, there is just to mention this, this link has a ton of resources at it, and even more than I have here. So this is stuff that I'm thinking of looking at and things that I've been compiling. Okay, I wanted to put this algorithm in the syllabus somewhere. Anyway, okay. So let's see, how am I doing here? How am I doing? Store, I mentioned, machine learning syllabus. Oh, okay, we're good. I got through all this nonsense. Now it's time for that doesn't work. It doesn't work the way that I want it to, but I'm going to work on this. Okay, work from the community. Okay, so I've had a lot of people submit things to me in the last couple days, and am I at 30 minutes yet? No, I'm not at 30 minutes, so that's okay. But I'm going to try to just click through these so I can start getting to the tutorial stuff, because I know a lot of people are interested in that. But I want to show some of these wonderful projects. Here is one made by Jerome Martinez called the Maze Runner. This looks like, what are these? Oh, themes. Look at this. You can have a little, I love this, different color themes. I can change the size, and it looks like it is, this is now running in P5.js. Wonderful. So this looks like quite related to making a maze and solving the maze at the same time. Great work. Thank you. Let's now look at Arno has submitted a couple projects that are for kids. This is a web app to help your child express his or her feelings and find a solution with you. So let's look at it in French. Comment vas-tu? Can you hear that music? I love it. I think I'm supposed to, oh yeah, I am afraid, peureux, afraid, right? Very afraid. Qu'est-ce qui pourrait t'aider? How can I help you, right? Yes? Sleep. I need sleep. This is awesome. Okay, I'm about to try this with my own kids later. I keep saying it. And then Arno, has another project about teaching kids to tell time, which is really, I think, exciting, innovative use of some interface stuff here. So I can like turn the minutes off and off. I can change the hours and the minutes, and I can try to guess, I guess is the idea. So it's hidden, but now I can show the time to find my answer. Great work. Lost GH Bear. Somebody in the Slack channel, let me know if that's working, and I'll show it if it is, if it got fixed. Let's go to Taco Bank on Twitter. This is a wonderful, one of the things that I love about what's happening on Twitter and Instagram, and a lot of artists are sharing short little animated GIFs of simple algorithms. And this, from what I understand, is made only with the arc function in processing. So I love seeing stuff like this. So if you make stuff like this and share your work this way, please tag me on Twitter so I can take a look at Schiffman. So this is Taco Bank on Twitter. Okay, now Alka submitted a bunch of code pens. This is a really nice use of oscillating simple harmonic motion. There's so much beauty you can find in just the simple sine wave through geometry design, layering, offsetting, period, frequency. This great work. I love to see this kind of stuff. Let's look at this one. This is me. The spiraling parrot. Gotta love that. All these links, by the way, when this video gets archived, links to all these will be in the description. And here's another one. This is really, so what I love about this is we can see the classic sine wave pattern that we're used to, but now we have these circles that are really just moving up and down along a single axis with harmonic motion. We can see the relationship between the graph of the sine wave and the harmonic motion of a single object moving up and down or left and right. Great work. Okay, I'm seeing in the chat that Lost GH Bear's project is working, so let's try this. Now, one thing I'm worried about, so I have a problem. I'm gonna do this, I'm gonna throw caution to the wind, but if somebody submits to me a project that uses audio in it, and the audio is not something that I have a license to use on the YouTube channel, I will get a copyright notice in the video and the live stream. So I just have to be careful about that, but I'm gonna throw caution to the wind here. This is using the microphone, so it's no problem. Hello. Hello. Oh, I should. As always, I always forget that this dot, and then do this dot, and then do this dot. This is Lost GH Bear's project. And this is Lost GH Bear's kitten song.
What else is there? Yes, kittens. Thank you very much. Kittens and rainbows and cupcakes. Notice that. Look what I get. I'm really losing my mind. Okay, let's do it.
Aerobics. Is this like an exercise show? Okay. Okay. So thank you, Lost GH Bear. This is great. This is one of the wonderful things you can do with P5 in the browser is get microphone input, visualize that input, frequency analysis, volume analysis, that type of thing. There's no audio. Oh, were you not hearing that audio? Oh, that's so funny. Did you not hear the song? Okay. I don't know what's going on. Okay, I'm going to keep going. And then this is from Robin, who writes, I'd love harsh feedback on this one. It's supposed to be a dynamic logo for website usage. Once design is approved, it will be adapted to fit inside a small DOM element powered by a footer. Okay, so let's take a look at it. And those of you in the chat, or I don't know if how, Robin, you want to receive feedback. But so this is an interesting use of computational design, which is to say, I want to make a logo that is dynamic, it's procedural, it's maybe different every time, or it's animated. And so there's a lot of examples of this. And actually, if you're interested in this topic, a reference that I would really recommend is, what's it called? Programming Design Systems. by Rune Madsen. And I'd love to have Rune as a guest sometime. This is the class. I want the book. Here it is, Programming Design Systems. Rune, I think I probably mentioned this before, is writing a free digital book that teaches a practical introduction to the new foundations of graphic design. So foundations of graphic design through the lens of computation, algorithms, code. And even if I were just, we saw Alka's project about, where are the chapters? About, I think there's one, I thought there's one about the sine waves. Somewhere here, a chapter. But anyway, I'll let you guys dig into this more yourself. Okay. Okay, here we go. Now, so these are some things. So the be nice equation, which I'm now officially calling it the be nice equation because, we could solve a lot of the world's problems if we could actually just write an equation that would help people understand how to be nice. Maybe that equation will do that. Whoops. This is so this was the fractal spirograph. There's a trash can over there. It didn't go in it, but this is the fractal spirograph, based on the fractal spirograph code challenge that I did. And you can see here that what I love about this is it's the same idea, but has a lot of now an interface that I can change things. So let's play around. Let's put the circles inside each other. Let's add a bunch more children. Let's change this value. I don't know what this is. Oh, let's do this. I don't know what I'm doing here. Let's change the size or the speed. I'm doing a terrible job. Show circles, show drawing point, show as points. Look at this, path color. So pause animation. So I kind of messed it up. Let's refresh it. Just to, children, I thought if I get more and more children, yeah, there we go. So anyway, so I encourage you. This is a lovely thing this is a thing that I love to see, which is taking an existing system, evaluating what are all the parameters of that system, and then making an interface to control all those parameters to come up with a kind of design idea. And this is a really nice example of that. So thank you to HABLWGQ on GitHub. This is from Gomako. This harkens back. I'm like really, these tissues. It's a new shtick here. Tissue shtick, which is probably not good. I didn't answer the question. So I'm gonna ask Lost GH Bear's question in a second. So this is, I don't know if this is built. Oh, it does say it's based on my example. But last fall, the course that I taught at NYU and did a lot of videos about involved programming with text. So what are some algorithms and systems to generate text? And this is a technique called a diastic, which is pioneered from American poet Jackson Maclow. And the way that it works is you get a seed phrase and it picks up words based on the letters in the seed phrase from the seed text and generates a poem out of that. So I can hit go and I can refresh and I can get different ones. So this is a wonderful, what I like about this is just the kind of simple interface and design of it, the playfulness of the algorithm, and so this is great to see. So I encourage you to check out some of those videos and check out this work by Gomako on GitHub. Okay, I'm done with my community set, but I forgot that that Lost GH Bear had a question. So if you recall back to this particular visualization of microphone, Lost GH Bear asks, can you give me any advice of new ways to visualize in addition to what is there? So first, I would just like to throw that question out to the chat. So those of you who have ideas of different things that Lost GH Bear might try, please write those in the chat, and hopefully Lost GH Bear can read along. I would say, do I have any idea? Here's the thing. To give feedback on a project, I think as often it's too easy to say, you know what I think is a cool idea? Why don't you try to do it this way? And so, what I would kind of more say in terms of thinking about critique and feedback on a project is more to kind of think about asking questions like, well, what is it that you're trying to make and what is it that you're trying to express? And is the idea to create, what's the context here? Who's the audience? And so I would think through those kind of details a bit more to try to inform some of your design decisions. At the same time, I think there's a lot of value in just kind of experimenting. So go through and find a lot of examples that you like the fractal spirograph or the Perlin noise terrain, and look at what the parameters of those systems are, and then try to plug those parameters into the volume of the sound or the frequency array of sounds, and see what kind of results you get. So I think on the one hand, it's thinking about context, audience, meaning, like what are you trying to express with this project, and who is it for, which might give you some more specificity in how you design, but also simply just playfulness and like just trying out a lot of different visual ideas. And you've done that here. These are some, the graph is quite standard, but look for some non-standard examples. Okay, so I'm just checking. I'm getting a message that my NES Classic is arriving soon. Anyway, I'm just checking here because I want to make sure there's no urgent messages on my phone, which there aren't. Okay, so now we're really ready to get started with what today is for. It is 11:30. It's 35 minutes. So I like the introductory stuff to not be any longer than 30 minutes, which I ideally like 15 or 20 minutes. So I apologize for that going on a little long today. Okay, now let's see what we can do. So I am going to, I'm looking here, okay. Ooh, that's very loud. I love that. Okay, so let me see. This is, now I'm to here. So this is what I want to do. Oh, first of all, okay. People are talking in the hallway. I can hear them. I want to pick up with, oops, this camera is off. A topic that I started yesterday evening. It's Crazy Person Whiteboard, because in yesterday's live stream, I focused on the broad topic of physics engines. What is a physics engine? Why would you use a physics engine? What kind of features do physics engines have? And what are some possible physics engines that work in different contexts, whether it's a programming language or running something in the browser, that sort of thing. So I did it, and then oops, this camera is now off. Hold on a sec. And then, if I come back over here, I made an example. So let's pull up that example from yesterday. Actually, I already have terminal here. And I can probably just run the server again. And I can go to, so if someone wants to tweet at Leah Brew, I shouldn't say this because now everybody's going to do it. I was just going to say the creator of Matter.js, which is the physics engine, was watching some of the stream yesterday and sent me some excellent advice, which I'm going to read some messages that clarified a few things. So this is the example that I built yesterday, which is a simple example using the physics engine Matter.js to handle collisions and also the physics of the system, and rendering with P5.js. So what I want to do is continue this. Now, okay, let's see if I'm back. Let's see. Hopefully I'm back. Okay, so it says to me that I'm streaming, so I'm going to assume I'm back. Now, I don't remember where I left off. I should have used that moment for a P break. A P5 break. Okay, so one thing I want to do to this example is I want to improve it a little bit. So I need to leave the code as is. Then I want to make some comments about it. So I need to leave I want to leave the code as is. Okay, so I'm going to make a new folder, Matter.js. I'm going to put this in here. I'm going to call this 01, and then I'm going to say 02. Just going to do this. So I don't think this will get included in a. So how am I, like, I need to move this. This can be over here. Okay, so one thing I want to do is I want to create a I'm just going to make a boundary object, which is a little bit silly because I could, I'm going to make a boundary object, which is really just a, the same thing as one of the box objects, but with is static equal true. I'm trying to think if this really, this is unnecessary, but I'm going to do it anyway. because everything else can stay the same. Whoops, this did not get saved where I thought it would get saved. Oh, I'm in the wrong place. I want to, shoot, sorry everybody. I moved things around. Don't save. So hold on. So if I go here, and open the console, and move this out a little bit further here, what's happened? What a disaster. I see. This is where I want to be. I made a new directory by accident. Oh, of course. Okay, don't worry. Everything's going to be back in a minute. I just need to get myself set up here the way that I want to be set up. Hit refresh. There we go. I've got 2 examples going. I want to then go to the desktop, and I want to look at, forget about this for a second. And then I want to open up this in Atom, almost there. And I want to go to this second one here. Okay, so what I want to do, I want to improve on this example, but there's so I'm going to O2, but there's a big problem with this example, which is that I kind of hard coded the floor. So what I want to do is be able to adjust how the floor is, give it an angle, that type of thing, without having to hard code and change it in a bunch of places. So there's 2 ways I could do this. Number one is I could just make the idea of a box more flexible, and I could have static boxes and movable boxes. But ultimately, I kind of want to treat these things totally differently because this might change into something else later. So I'm going to have some redundancy. I'm not going to use this idea of inheritance, and I'm just going to do save as in Matter Basics. I'm going to make a file called boundary.js, and I'm going to, this won't be its own tutorial video, because I'm just going to do this really kind of quickly. It'll just be here in the live stream for you live viewers. I'm going to make a file called boundary.js. Actually, you know what? Never mind. We're gonna do a part 2 here, because this is what I'm gonna do is change these into circles and change the boundaries. Okay. Why am I doing something that is a tutorial that I'm saying is not a tutorial? Okay. So I'm in Matter Basics. Okay. Ready, everybody? So this tutorial, this particular video, this is a continuation of what I did yesterday. So I apologize to those of you who didn't watch yesterday's live stream. It is archived and available on my channel. You can go back and watch it. But in the end, all of these things that I'm doing will be edited into a sequence of shorter tutorial videos. So for now, I would just say enjoy, watch along. You can go back and fill in the missing pieces later. Okay. Because there's a bunch of things that I want to do, and then I think, yeah, okay. Hello, welcome to a second video about using Matter.js. So in the previous video, I kind of ended with this, which is just a simple demonstration of falling rectangles landing on a ground. So I want to do 2 things in this video to expand on our sort of knowledge and sense of what Matter.js can do. I want to change these falling rectangles into circles, and I want to change the way that the boundary works, in that I want to make this bottom boundary, I want to be able to put it as an angle and maybe put a bunch of them. So there's one of the Matter.js examples is essentially this. Let's just go to the website, because I'm going to need the documents open, the documentation open. So at some point here, one will come. Let's wait for it. There, no, that's not it. Maybe that was it. Maybe it's not there. Look at all these demonstrations. There it is, this one. I want to kind of make this. That one, do you see that one? So let's, so what do I need to do? So first of all, I did this sort of terrible thing where this bottom thing, which I'm calling a boundary or the floor, was kind of hard-coded. So let's fix that. There's going to be some redundancy here, but I'm going to live with the redundancy. I'm going to make another JavaScript file called boundary.js. That's in the right place. And then I'm not going to forget this time, in index.html, I'm going to add another reference to boundary.js. Now what I want to do is in this ground variable, instead of creating the body right here, I want to say new boundary, which is my own thing. And I'm going to use those same arguments. 200 height, and then I'm going to get rid of options. And then what I'm going to add under options is in the boundary object. Whoops, where's that boundary object? Oh, it says box here. Wait. Ah, yeah, box. This needs to say boundary. And I'm going to add is static true. So by definition, this idea of a boundary, I mean, boundary is probably the wrong word, but is going to be something that doesn't move, that's inflexible, that's in one place in the code. Okay. So now I should then be able to say, and let's make it a different color. The boxes are kind of like a white outline and a gray interior. Just so we see that it's something different, let's give it a white outline and a, I'm like afraid to use color, a black interior. Okay, so everything should be the same right now. I'm going to change things about boxes versus boundaries. But now if I make the ground a boundary, then I should be able to just say, I don't need any of this down here. I can just say ground.show. So if I ever change the way the boundary works, then I don't have to worry about that. So let's see. So this still works exactly the same way. And you know, I'm like annoyed with the fact that the outline is bleeding off the edge here. So I'm going to kind of for no good reason change this to like, you know what I'm actually going to do is I'm going to go into boundary and not have it have a stroke. So I'm going to say I'm not going to have any outline to that color. I'm going to say no stroke. Okay, there we go. This is more like what I want. Okay, so we're in good shape. Now here's the thing. I want to demonstrate a problem that happened in the previous video. Let's go to this boundary where I'm creating it. And it has a height right now of 100 pixels. It's very thick. I'm going to give it a height of like 5 pixels. Now you can see it's there. There's like a boundary there. And let's just see now. Now it's actually working just fine. So we're lucky here. One of the things I did yesterday was add the update time step in my draw loop. So there's sort of more physics updates per time that I draw it. But I have a feeling that if I go back to what I did yesterday, which is just tell the engine to run in the background rather than update it manually, we might see the problem I had yesterday. Let's go back here. Okay, let's see. Can I get this? Oh, there we go. So some of them disappear because that boundary is not very thick. They're kind of like, the physics gets confused and they're skipping over it. So Liabru, the creator of Matter.js, sent me a message saying, so in the in-engine.update, that update function, there's a correction factor. Okay, I don't know what's going on today. I used to have this problem where the streaming computer would freeze and get disconnected. And that problem, I used to have it and it just went away. So I actually switched, I'm using a piece of software called Wirecast. Wirecast, it actually was having this problem, so I reverted to an older version of Wirecast, and the problem went away. Now I'm having a different problem, so I went back to the newer version. So hopefully this is going to be fine. But okay, so I'm going to try to figure out where I was before, and this will get edited eventually. So okay. So let me see here. So engine update, thank you. So I'm going to change right now having engine, I'm not going to say engine update in draw. I'm going to go back to having engine.run in setup. So this will allow, with engine.update, I'm manually telling the physics system to move ahead a moment of time every time through draw, which is kind of good. It's like move ahead, draw, move ahead, draw. With engine.run, it's going to run on its own behind the scenes, separate from how I'm drawing. You'll actually see stuff appear to be moving faster because the engine's going to be running at 60 frames per second where my actual draw loop might be less. So let me just do that. Still works fine, but I don't know what's better. Anyway, I feel like I have more control, but what I want to show you is the issue is if I now change the that boundary at the bottom to something like it's only like 3 pixels, you can see that some stuff is working, but let me go up here. Look, sometimes the rectangles like fall through the bottom. Did you see that one? Oh, I was standing behind it. It fell through. Let me find it to get another one. Come on, happen, bug. There you go. You see some of them are falling through. So the reason why this is happening is because there aren't enough time steps. It's checking where the object is, then it moves it and checks again, and it's actually jumped over the obstacle. So there's a number of ways we could fix this. Number one, the way I fix it is just like, okay, just make the ground thicker, and now this problem can't happen. And so that's one way of fixing it. But there's actually, I'm going to put engine.update back into the draw loop. If you look in the documentation, which I showed yesterday, there are variables here. There are arguments you can pass through about time steps. And Liabru on Twitter, the creator of the Matter.js library, wrote to me and said, the issue of skipping is best solved like you did by using thicker floor or a smaller time step or multiple updates per step. So that's something you can do. But Liabru writes, there is a feature called continuous collisions that I am working on that solves the issue for any time step. So that's coming forward. So that was great to hear that. It's so wonderful to like do a tutorial about a physics engine and have the creator of the open source library weigh in and provide feedback. So thank you for that, Liabru on Twitter. Okay, so now let's keep going with this. The next thing I want to demonstrate is I want to see if I can turn that obstacle at an angle. So let's look at the boundary object. So this is where I'm creating the rectangle object, and it's the variables in this .body. So what I'm just going to do is I'm going to say console.log this .body. Let's look at what some of the properties are. And here's a property, angle. So this leads me to believe that I could most likely just set the angle to a value and it would change it. So let's try that. Let's try saying something like this.angle equals pi divided by 4, which is about 45 degrees in radians, right? Pi divided by 2 is 90 degrees. So let's do that. Okay, let's see here. Let's try to look here. Console.log angle. Did that come through? Ooh, 0. So why, if I set it up here to an angle, does it come out as 0 down here? What if I need to do it? What if I do it after I add it to the world? No, what am I missing? I'm just being silly. It's this.body.angle. So when I say this.angle, this dot, when I say this dot angle, I'm adding a property called angle to my boundary. But remember, my boundary object is simply a wrapper, really, for the Matter.js body object. So I need to say this dot body angle, and that should fix this for me. There we go. So now we can see, ooh, whoa, weird stuff happening. Crazy weird stuff happening. So what have I missed here? Am I drawing it the wrong? Why is this? I like what it's doing. It's kind of like some weird, crazy graphic thing that I didn't expect. Let's think about this. I got to debug this. What have I done wrong? Whoa. So this is the classic thing that happens with physics libraries where I'm clearly not drawing it the way that the physics library thinks it is. Is it possible that it wants, I don't think it wants angles in degrees. There might be an issue with setting the angle. Angle previous, angular speed, angle velocity. Oh, it has an angular velocity, which it really shouldn't. So maybe, did I give it an angular velocity by accident somehow? Is there an initial angle? Can I do this? Is this better? If I just set it as an option at the beginning? Let's try that. Ah, there we go. Okay, so it looks like this is a classic thing that happens with Physics Engine. I violated the laws of physics by just setting its angle directly. The only reason its angle would change is if a force, something was probably added to it that instigated the, oh, and I'm not looking at the chat. So I have a feeling that you just can't set the angle directly unless you kind of work with the mechanics of how the physics engine is behind the scenes. So if I want to change its angle while it's running, I need to maybe apply an angular velocity or an angular force to have it turn. So that's nice to see that that's fixed. So let's add a bunch of these. Let's go to sketch.js and let's say var, just call it boundaries as an array. And what I'm going to do is I'm going to create I'm going to create a bunch of them. Let's say boundaries dot push. So let me just push this boundary. Now here's the thing. I want to give it an angle. So let me give it an angle like the new boundary also has an angle of pi divided by 4. So I can go into the boundary object and add another argument like a for angle and put that in here. And so what I want now is to, let's make it like pi divided by, let's just put some values in like 0.3 so it's at a slight angle. Let's not make it so tall, 50. So let's see here, and and then what I want to do is here say for var I equals 0. I want to render all of the boundaries. For some reason today is the day where my lines of code are so long and going off the edge. Boundaries.show. So let's see what I've got going on here. I have some errors. Sketch.js line 20. What did I not do correctly here? Oops, I got the semicolon in the wrong place. Matter.js, type of undefined, sketch 22. I don't need to add it here. I wonder if that also caused a problem because I added it twice. But because it gets added, the thing that I did is added here. So I don't need that other. That's been a mistake that's been in the code. And let's see here. Okay, so we can see here this is working. I've got a boundary there. And so now let's add some other ones. Let's add another one at height divided by 2. And let's have it go the other angle, the other direction. So now, and let's make these shorter. Width times 0.6 or whatever. I could hard code values in. And so now, and let's move this one over. Oops. Let's move this to 250, 150. So you get the idea. Oh no, that's not really right. Let's make this one, what's the size? Let's make this one 300. Let's make this one 200. Let's make this negative 0.3. Let's make this, I'm sure I could make a clever loop. There we go. This is kind of what I was looking to do, but I want this one now to be much higher up, which this bottom one, this is the higher up one. Let's make that even higher up, and let's make this then just like 20 here. Okay, so you can see what I'm trying to do here. I'm trying to create a system now the friction is quite high. Look how much the friction is causing these things to stop. So let's at least fix that. In the boundary, the friction is 0.3. I can't remember, is it 0 is no friction or a lot of friction? That looks like they're sliding more or less, I can't tell. Let's go to the box and also give it no friction. There we go. So now that's no friction, but maybe I want a little bit of friction, and maybe I want a little bit of friction on each. And then also what I said I wanted to do is I wanted to change the rectangles. Boy, that's really a lot of friction. You can play around with those values. I'm going to put 0 on the boundary. Right, look at all that friction. Oops. Really? Was it really no friction with 0? Yeah. What I'm going to do is I am going to now also I want to change those rectangles into circles because why not? So I'm going to go into the box, and I could change the name of it from box, but really what I want to do is change this to circle. And I have a guess that what circle wants is maybe XY radius. So XY radius, I'm going to change that in Sketch to just make, when I click the mouse, to add one with a single radius. And then I am going to change the way that I draw it to be an ellipse with an R instead of a W and an H. So let's do that. And here we go. What am I missing? Sketch.js line 30. And I boxes.push new box, mouse X, mouse Y. This closes random. This, I need another parentheses there. And here we go. Now it looks like my size is off. So let's go look at the documentation. It's kind of working. We can see the circles are like hitting the, they're kind of like above the actual, they're actually above the actual boundary. So let's go to the Matter.js documentation and let's fix this. Boy, I'm spending a lot longer on this little example than I meant to. Let's go to the Matter.js documentation. Let's go to bodies. Let's look for circle, X, Y, radius. I know what the problem is. I was right all along, but P5 doesn't expect a radius, it expects a diameter. So all I need to do to fix this is actually where I'm drawing, and let me call this circle just to be consistent. And in sketch.js, I'm going to now call this circles, and I'm going to change this to new circle. And I've got to go through circles.length and change this to circles. And now what I need to do, I'm going to leave this as box.js just for right now. I need to say this.r times 2. And now, whoops, sketch.js line 30. I missed one reference. Circles.push. So we can see, there we go. Now these are kind of large. So I know that, let me just change this between 5 and 10. And I'm also going to do mouse dragged. So now what I can do is just add a lot of circles, and we can see I mostly have that demo we had before. And actually, I'm kind of along the way of almost creating a kind of liquid simulation. Because if you could imagine if you were to change the way the behaviors of these kind of work, make these really, really tiny, you would almost have something that has a kind of like liquidy-like quality to it. Okay, so now what I've done is I did a second video where I showed you a bit more about how I can have two different kinds of objects, a static one. We looked at circles. We kind of played around with friction a little bit. So hopefully this helps you see a bit more about using Matter.js. And in the next video, what I'm going to show you is how to actually have the mouse interact with this so I can kind of drag these objects around and toss them. And I'm going to look at a concept called a constraint for that. Okay? See you soon. In the chat, C. Manny is telling me to increase the restitution to 0.95. In which object? Let's try it here. And let's add it also in the boundary. Ooh, yeah, it's more bouncy. Okay, share the code. The code will be shared. So I always, after every live stream, I take all of the code, I upload it to GitHub, et cetera, et cetera. How are we on time here? It is noon. It is noon o'clock. That's not so bad. I got lots of time left. Oh, this is good. I'm definitely going to need a P5 break at some point. Okay, so now, the next thing I would like to do is look at constraints. So what I'm going to do to this particular example, what might I do to, oh, you know what I really need to do here is I need to remove the objects after, so let's test something. So I realized I forgot something that's kind of important here. Let's go to, let's change this to just add objects in the draw loop. And I'm going to add them at the top every frame. So let's let this run for a little bit. I'm expecting that eventually it's going to start to run really, really slow. I'm kind of amazed that it hasn't yet. So the issue is, of course, that I'm creating all these objects and I'm putting them in an array. And that array is getting bigger and bigger and bigger and bigger and bigger. And I can start to see it now. It's really starting to chunk along. So even though the stuff is way off the screen, there's a couple issues. Number one, my P5 code is still processing all this stuff. But even worse than that probably is Matter.js is still trying to do all the collisions for all this stuff that's way somewhere where we don't even see it. So what I need to add to this is some way of removing objects. So I'm going to do that in the next sequence. And so the things that I want to add are, and let me get myself ready here. I want to go to constraint maybe. Matter.constraint. I want to look for it. Mouse. Mouse constraint. So I want to create a mouse constraint. I should look at this in advance. Mouse constraint, mouse. I guess I could just look at the example. Matter.js. Let me look at this. I'm looking for, where's the examples? Examples. Examples. I think a lot of these just have the mouse constraint in them. Let's just look at this one. I don't know. Mouse constraint. Let's just look just in advance to sort of see. Mouse equals mouse.create, mouse constraint. Okay, I need to create a mouse and then create the mouse constraint with the engine, with the mouse, and some. Okay, so I think, and then add it to the world. I think I'll be able to figure this out. And so I need both to create a mouse and a mouse constraint. Okay, so we're going to try that. So let me first back up here and just put it back. I want to save what it was when I last left off, which was this. And now I need a new 03 matter mouse. Okay, so what I'm going to add now is the mouse constraint. Okay. Okay, so let's do that. Okay, so I want to make sure I'm in the right one. Sketch. I'm in the right one now. And now I'm in the right one here. Okay, here we go. Which is better to learn, JavaScript, Python, or processing? These are some very good questions. All of the above. How about that? Mouse constraint. Okay. Here we go. Okay, I'm back for more Matter.js. It Matter.js to me to make, never mind. It was going to work, but it didn't. Okay, so what I want to do, this is what I left off in the last video. And the thing that I want to add to this is a mouse constraint. But you know what? There's something that I really should add first, which is that even though there's all of these, I'm going to call them particles, circles, and they leave, and then I add some more, I've never actually told my code or the Matter.js engine that those circles have left the screen. We can now ignore them. So it's going to start to run very, very slow after a while. So first of all, let me just change something here to demonstrate this, which is to say, instead of adding circles when I drag the mouse, I'm just going to, every time through draw, I'm going to add a circle at the top. And just so there's going to be a new circle every frame. So now it's doing this automatically. And I kind of want to move that top one a little further down. That's not really a good reason to do this, but let's do that. Yeah, so this is a little better to sort of demonstrate, just to see. So now I move that a little bit down. So we can see after a while, I'm sure this is going to start running very, very, very slow. So two things I need to do. Number one is I need to remove those objects from my array when they're off the screen. But number two, I probably also need to tell the physics engine, stop trying to calculate geometry with them. So I know how to remove them from my array. So let's do that first. So here, in this is where I'm kind of looping through and drawing all of them. So I can add some code, something like if circles.is off screen, then circles.splice I, 1. So what is this doing? So this is the idea here. If circles index I, if this particular circle is off the screen, then I'm done with it. And splice is a function that removes an object from an array. So I want to remove the I object from the array, and I only want to remove one object. So splice allows you to remove like I and then the two after it if I wanted to, but I don't want to do that here. So is off screen, this will just work, right? No, it has no idea what is off screen is. That's not some sort of function that exists, but it's something that I can write. So if I go into box.js, which really should be called circle.js, I can write a function called is off screen. And what do I want to do? Well, first, I want the position of the particle. So I can say var pos equals this.body.position. And now I can say, there's a lot of things I could evaluate here, but I'm just going to do something really easy. If pos.y is greater than height plus like 100, like it's not only at the bottom, it's like 100 pixels below the bottom, then return true. And yes. Actually, so let's do this here. Everybody always complains. I like to write silly code like this, just to really kind of illustrate exactly what's going on. If this is true, return true, otherwise return false. But notice the way I just said that. If this is true, return true, that's kind of silly. This whole thing evaluates to true or false. So something I can actually do to make my code a bit more concise is just return what this evaluates to. So return true or false. Is pos y greater than height? So now this should kind of work. And it's actually, I'm expecting it to work. So let's just look here at, what was this called? Circles.length. 144, 145. So it's got to be working, right? If it's 145 now. Oh, whoa, but look what's going on. See all this like crazy flickering? What's that flickering? So this is why you need that. What I've done, there's a flaw in what I've done, a major flaw. And I do have a video where I go through this, but I'm going to mention it right now because you don't want to go find that other video. Oops. So this is an edit point, Mathieu, sorry. So what's going on here? I'm going to do a quick explanation of this. Here's the array. Here's all the spots of the array, 0, 1, 2, 3. I'm looking at spot 0, it's fine. I'm looking at spot 1, it's fine. I'm looking at spot 2, oh, delete it. So then this moves over here. What used to be in 3 is now here. So now I move and check the next one. Let me explain this again. Hold on, I realize there's a way that I like to explain this that's a bit better. I'm going to try this again. I just realized, okay. Okay, so what's the issue here? I'm going to do a quick explanation. Let's say I have an array, and it has circles in it, A, B, C, D, and E. And C is actually the one that's off the screen. C is the one that's off the screen. A, B, D, etc., E are all on the screen. So I check 0. Oh, it's on the screen. I check 1. Oh, it's on the screen. I check 2. Oh, it's not on the screen anymore. Delete it. So I remove it from the array. You know what happens when you remove something, splice something from the array? This is what happens to the array. Those two elements move down one, that's gone. So now check 3. It's fine. What happened? I checked A, B, C, and then I checked E. I never actually checked D, because when I was checking index 2, I removed it, and then D slid into index 2, so I just went on and checked E. So this is what's happening. I'm kind of like skipping them, and then I'm also like not rendering one because it like moved and it didn't get rendered, which is why it's flickering. So what I actually need to do, there's a bunch of ways I could resolve this. I'm sure there's like a very fancy JavaScript using some kind of sophisticated array function that you all will let me know in the comments. But a quick way I could do is just go through the array backwards. I could also do something like just say I minus minus. Like, let me just back up one. Let's add that into the code. And now we should see, we don't see that flickering problem anymore because I'm not skipping any. So, but I could also loop through the array backwards. And now I can just check to make sure this is working. You know, it's growing, but then it went down. So definitely things are being removed. Now, the thing is though, I only removed them from the array. I think Matter.js is still thinking about them. There's still the world. Matter is like, oh, this world is full of circles, and I'm going to figure out if they're bouncing, even though if they're like thousands of pixels below the screen. So I don't actually know how to do this. Let's look at the Matter.js documentation. This would be something that you would do in the world, right? Because I say world, here I say world.add. That's how I add a body to the world. I'm guessing there's a remove function. So let's go into the documentation world. We see that there's an add function. Now add body, that's add composite, add constraint, all bodies, all composite, all clear. That maybe clears everything. Clear. How about remove? Remove. Generic remove function removes one or many bodies, constraints, or composites to the given composite, optionally searching its children recursively. Oh, so there's all this kind of like ways that the bodies can have relationships, that things can be like sort of tethered together. If I remove one, should I remove all the other ones? But we're not in that sophisticated of a space right now. So I'm just going to say, I think what's going to work is if I go to box, if it's off screen, what I might want to do is also do something like circles, because I might want to do this in other place, like remove from world. Okay, you guys can think of a better function name for that. Remove from world. So this dot remove from world equals function, and I'm just going to say world dot remove world this dot body. So I'm pretty sure that, and there's a way that we can test this actually. So let's run this. So there's how many, and I probably shouldn't have, hold on. Let's first comment this out. So right now I'm not calling my own remove from world. So I am going, and I'm going to get rid of these console logging things that are polluting my, probably in the boundary. Yeah, sorry. Okay, so there's my array, which is called circles. 136. Now there's also an array in Matter, which I believe is probably world dot bodies. I think the world itself keeps track of everything that's in it. That's an array dot length. 913, quick, circles dot length. 147. So you can see Matter.js thinks there's 913 things, whereas I think there's only 147. So now what I should be able to do, and let's be more precise about this actually, let's just in draw, let's console log these. Console log circles.length, and then what did I say? World.bodies.length. So let's look at both of these. So we can see that they're kind of working together until they start to leave the screen. I'm deleting stuff, but this just keeps going up and up and up and up and up. So now, what do? If I put back in my function where I am additionally not only removing it from my array, but telling Matter.js to remove the body itself, I think we're going to see this now be correct. And there we go. Right? Wait, hold on. It's not exactly in sync. I mean, it's a little bit off. Why is it off? Oh, look at this. Oh boy. Oh boy. Something weird has happened. Look at this weird bug. Certain ones have stopped and been removed. I have a feeling this has to do with the way that I'm going through the array. Oh, I know what's the problem is. Look at this. Boy, I've been really careless. Splice it and then remove. I removed it from the array, and then the stuff slid down, and I told it to remove the one after it, which wasn't actually removed from the array. So that was a really bad bug. This has got to be first. So there might be a different way I could think about organizing this to protect myself from that kind of error, but this, at least now, we should see, whoops, we should see this fixed. I'm in mouse, which I haven't even done yet. Okay, so let's look, let me refresh here. So let's see here. Now here we go. Once they start getting removed, we should see that they're staying in sync. There we go. Now one thing you'll notice, if I just say no loop here, just to pause the sketch for a second, you'll notice that the number of things that Matter.js thinks exist is always 2 more than what I think. That's because there's 2 boundaries. So this is, I think, an interesting question, which is I've introduced a great deal of redundancy in that I'm keeping track of my own arrays of stuff, but Matter.js actually keeps track of everything itself. But I'm doing that just so I can have total control over the sort of visual design and management of the entities and not have to rely on, because I want to keep these things in separate arrays, whereas Matter.js, the bodies array keeps everything in one array. But there's reasons why you might not do it one way or the other. But okay, so I said this was going to be that I was going to introduce the mouse, but there was enough here just in looking at removing bodies from the world that was a pretty good topic for this video. In the next video, the next thing I'm going to add is a mouse constraint where I can click on these things and drag them around. So I'll see you in that video. Okay, I looked at this chat. But you guys, I think I found the chat was okay. The chat gave, but I think what you're telling me in the chat is what I already figured out. Okay, so now let's keep going here. 12:20. I'm good with time. Am I good with mental energy? So this was matter remove, and now 04 matter mouse. Thing is, the question I have here is, this isn't the best. You know what I'm going to do? I'm going to do something a little bit different, even though it's not what I said. Yeah, I don't know what I'm doing here. Shoot. I think I messed up. Whoa. Oh, I renamed stuff and then it got confused. I think I can get rid of this. I think what I actually want to do is go into a different example. So this chat song, never forget to look at this chat. What I think I want to do, let me go to Matter mouse, is actually not do Matter mouse right now. The mouse does not matter. And I want to, which one am I in? I'm in 04. So let me go back to 03, and let me get rid of this console log, or just comment it out. And what I want to do, make sure this is right. Okay, what I want to do actually, and I'm going to start kind of over from scratch. Matter constraint. So what I want to do actually is I want to look at constraints between objects that aren't that aren't the mouse, and then do the mouse constraint after, because that's going to make more sense. Especially because if I make a little swinging chain thing that things are attached, I'm going to want to swing that around with the mouse. Whereas this example is not as conducive to clicking and dragging these things. So that's what I'm going to do. Okay, I want to get to some coding challenges. I want to get to the text string geometry thing. Oh, oh. I have about an hour. I have about an hour before I really need to get going. So that's still a solid amount of time. Okay, so I need to start over from scratch a little bit. And I'm going to leave these as circles. Okay, so let me close this. And I'm going to rename this to, circle. I'm going to call it a particle. I like the idea of calling it a particle because that kind of, connects to other things. Let me just see here. Particles. I'm sure I could do a find and replace. I'm just being lazy. And particle. And index.html, particle. Okay, so this is the same. Oh, I'm in matter.remove. Okay, that's fine. I want to look at matter.constraint and sketch.js line 49. Yeah, I don't need this though. Okay, great. Okay, so now what I want to do is get rid of this. And I want to just make one boundary that's more at the bottom. And angle of 0. Oops. Okay, so I've got a blank slate here. So what I want to do is I want to create a swinging chain. And here's the interesting thing, and I guess I'm going to say this again in a second, but Matter.js has this idea of composites, and it has this idea of a chain that you can actually just create. But I'm not going to do it that way, which may or may not be a bad idea, but I would like to, I'm going to talk about this in the video. I'm out of water, but I got a full box of Kleenex. So things are going to be okay. I might not be hydrated, but my nose will not be running. Okay. Now. Okay, so let's see what's going to happen next. Okay. I need to, where's my eraser? Where is my eraser? Where, oh, where has my eraser gone? I found it over on the floor. Okay, I'm going to just erase all this. Oh, my sad little friend there is gone. Okay. Here we go. Okay, so now what I want to do is let's look at okay. Probably should just look at demos here and change this to the one that I want to look at is maybe chains. Yeah, this. Okay. Yeah, see, this is what I want to implement, but then I can actually click on these things. Okay. Let's see here. Okay. So where are we? Composites, Matter.js, and then constraint, create, options. See the properties section below for detailed information what you can pass. Body A, body B, ID, label, length, resting length, point A. The offset constraint from the center of body A, and then point B. Okay, this is tricky. There's a lot of tricky stuff associated with this. So, okay, so C. Manny writes, clearly you ignored my HTTP over DNS idea. I think you're maybe C. Manny is not talking to me. Okay. Adam has a console if I want, not by default. Oh, that's good to know. I should maybe consider looking at that. Okay. Let's get back to business here. A lot of things. These libraries are always more complex and convoluted than I imagine. Okay. Here we go. Oh boy, okay. Okay, so here I am back in another video about Matter.js, the physics engine. Now one thing I didn't really realize is Matter.js actually has a page on their website if you click on demos, where all of the examples you can look at as demos. And this is basically what I want to build. I want to create a kind of like swinging thing like this that I can drag around with the mouse. And one of the nice things about the demos, by the way, is there's a whole interface here where I can play with a lot of these parameters, density, friction, that type of thing. So in that case, what am I saying? In that case, these are great to look at and sort of better than my strategy of like, let me make the example and keep changing the values. Obviously, I could like create a whole interface in my program, but a lot of that is here for you to play around with. So I highly suggest taking a look at that. Now, here's the thing. This demo, I looked at it in advance. This demo is actually created with... Okay, I'm muted. You know why I'm muted? You guys can all, since it crashed, I used this moment to take a break. Okay, so I'm back streaming, no audio, yes. There's actually an even newer version of Wirecast than the one that I'm currently using, and I wonder if, so I'm going to download that and see if maybe that resolves the issue. I haven't had this problem, but now I have it. Anyway, the good news is, oops, I didn't get, ooh, look at that. I didn't get to far, where was I looking for? Chains. I didn't really get too far in that tutorial. So let me just fix this over here. And let's get going on this next one. Okay, so I'm just going to jump right back in. Yeah, and maybe I'll switch to using Open Broadcast Studio, OBS instead of Wirecast, and see if that resolves the issue. The only reason I use Wirecast is it has some features that are really useful for me in that I can map hotkeys on a keyboard to different shots, so I can kind of like live change those. And some other features, but also I just need the time to have a day to like try setting up OBS. Okay, here we go. Oh, 10% battery. Oh, hold on, I'm gonna, just bear with me for a second here. I'm gonna do something, I gotta plug this in. I'm gonna charge something here. This iPad that I use for sound, the battery's about to die, so I might as well charge it while I'm not using it. Where is a plug? I need a plug. I've used all my plugs. That's crazy. I could plug it into, you know what, actually, this is probably gonna make something pop up automatically, but I will do this for a second, and I'm gonna plug this in. It's charging, and I'm gonna, yes, that's good. And here we go, quit that, okay. Oops, I am back. iTunes quit unexpectedly. Yeah, I want it to quit. Okay, I just plugged it into my laptop. Okay, here we go. Let's try to get this train going. Hopefully this train will have no further delays, no further track issues, that sort of thing. Okay. Here we go. Hello, welcome to another Matter.js physics engine tutorial video. In this video, I'm going to attempt to make something like this. Now, you might be wondering, look at that. That's a Matter.js page. So one thing I didn't realize in my previous videos is that Matter.js on the website has a page you can click on called Demos, where you can actually look at these different examples one by one. And one of them is for creating these chains, otherwise known as bodies connected by constraints. And those constraints can be springy, elastic constraints. And so there's a lot of things you can build from this particular idea. Now, another thing I'll notice about this demo page, which is great, is that it actually has an interface for manipulating a lot of these particular variables. So, you know, I've been kind of in the code just changing numbers and refreshing. Obviously, building an interface to sort of tweak and test different values is much better, and this is built in right into the demo page. So what I'm going to do is essentially what I want to try to do is recreate exactly this chain by connecting a bunch of these circular bodies by constraints. And here's the thing. So I was looking at the Matter.js documentation, and it actually has something called composites. So composites are, composites module, it says right here, contains factory methods for creating composite bodies. So this is what you can use actually, I just want to have a chain of things, or I want to have a stack of things. And there's even a composite for a car, which is really just like a couple shapes and some wheels maybe. But here's the thing, I'm going to do this video and make this tutorial without using the built-in composites. Certainly if what I want is a chain, using the built-in composite chain might make this easier, but I want to build this in a flexible way that I could kind of make anything. You know, I could make a chain that has branches coming out of it. So I want to have total flexibility to see what happens if I individually create all of the particles and constraints one by one and attach them in a completely customizable way. Maybe this is a bad idea, but I'm going to give it a try. Okay, so what do I need to do? So the first thing, just to sort of work this out, so okay, this is my program currently. This is where I am. All it has is a single ground body. So it's the same ground body that I've had in previous videos. I also made a change from the previous videos where that circle object is now called particle. But I haven't put any particles into the world. I could, however, put one. So I could say var p equals a new particle, and I'm just going to make it at 200, 100 with a radius of 10. And then I could just say in draw p.show. Oh, it's actually pushing particles into an array. So what happened? P is not defined. Oh yeah, but I'm using that array. So let me say particles.push p, and then let me actually iterate over that array with my non-for each loop. And just say particles index i.show. So let me just get one thing. So there's my one particle. Now I want to add a second one. What I want to do is I'm going to make that p1, and I'm going to say p2 is 200, 150, and I'm going to push both of those into the array. So there's two of them. Now these have no relationship. They bounce off of each other and move apart. What I want to do is I want to use something in Matter.js, and this same idea. So it's called a constraint. I didn't spell that right. Constraint. Like train is in there, I think, somewhere, right? Constraint. It's called that in Matter.js. But if I were in Box2D, this would be called a joint. If I were in Toxic Libs, it would be called a spring. So there's lots of other terms for the same thing. It's an entity that connects two bodies. Now it does not have any geometry. So the idea is if there are two particles, I want to be able to connect them with this thing called a constraint. But one thing to note about the constraint is it doesn't have geometry. So something will fall through it. So there are other scenarios where what you might want to do is make like a bridge. But it's sort of like a springy bridge where what you could do is make a bunch of rectangular bodies that abut each other, and then you could actually connect them with constraints, but there's very little space between them. So that's another scenario that I could do in a coding challenge or something. But here, I just want to be able to attach these two bodies. Now, this is always much more complex than you think, because there's a lot of things I need to set. I need to say body, which two bodies? So body A and body B. But also I need to say, where is the constraint attached? Is it at its center? Or, I might want to do something like this, where I kind of connect them from the edges. Let me, finding the button. So in Matter.js, I'm pretty sure has a way of doing this, and I think it's called point A and point B. So there's the bodies, and then the point is not the location of the constraint, but the offset of the constraint relative to maybe the center point of the body. Then I also need usually a property called like length, which is often the rest length. So you think about a spring, if you pull on a spring, it starts to but eventually it comes to a rest. So what is its sort of resting point where there will be no force, either contracting or expanding it? So the rest length. There's also, what else would there be? Maybe there's a kind of like strength option, like how, is it very rigid? Is it like a rubber band? That type of thing. So just to make this single thing that connects the two bodies, I need to set a lot of parameters. So let's go try to do that. Over here, okay. So what I want to do is, now I want to try to make a constraint. So let's go look. Constraint, I have that page open. Matter.constraint module contains methods for creating and manipulating constraints. Constraints are used to specify fixed distance between two bodies, blah, 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 all this sort of stuff, stiffness, springs, or elastic. So I think this is what I want, matter.constraint.create. So I'm going to say, I'm going to just make a variable called options. Then I want to say matter.constraint.create. Now, what I could do here is say, I could add another alias, just constraint equals matter.constraint, right? I think that's what I want here. And then now I can just say, constraint.create. So var, I'm thinking here, var constraint equals. So now I'm just going to, that word constraint, the more you look at it, the more it looks like it's spelled wrong. I think it's right. I want to create a constraint. And with options. So create options. So I could certainly put the object with all the parameters right in here, but I just want to have a separate object where I keep track of this. So what are the options? See properties section below for detailed information on what you can pass via the options object. Properties. Body A, body B, ID, label. These are probably things to keep track that I don't need. Length. So these are things that I need. So let's look. So body A, I want to connect P1, that's the first one. Oh, but it's not P1, right? My particle is my own object. Particles, the body is the thing that matter cares about. So P1's body to body B, P2's body. And then I also have point A, which is that offset, which I'm just going to make, how do I set the offset? The offset is an object maybe with an X and a Y. So I'm going to just have that offset be an X and a Y of 0. It probably does that by default. So actually, let's just not put it in there. But if I wanted to offset it differently, I think I would put this in as an option. And then length is probably good. So let's do a length. Let's give that as like 50 pixels between them. And then what was the last one? Stiffness. 1 means the constraint is very stiff. 0.2 means it acts like a soft spring. So let's try that. Stiffness, let's try like 0.4. So now, I am assuming what I then have to do is do world.add world, constraint. So I've also got to tell the physics engine to put that constraint in the world. So now I've created a constraint between those two bodies with a specific rest length and a stiffness. I've created it and I've put it in the world. So now let's run it. Oops, constraint. Oh, because it is spelled wrong. The more you look at it, the more it becomes spelled wrong because I spelled it wrong. Constraint. Yeah, that's why it's spelled wrong. So let's see. Look at that. Whoa, so you can see that constraint. Now let's offset it a little bit so we can maybe see more what's going on. There we go. So you can kind of get the feeling like they're constrained together. Now the thing is, I can't see anything, but I could draw a line between them. So now in draw, I could do something like line, this is a terrible way to do it, particles 0 dot body dot position. Oh, this is like the worst thing I could ever possibly do, right? Draw a line between this first one's X and Y, whoops, and the second one's X and Y. And let's see what we get here. Now, I've got a line, so you can sort of see. Now it sort of feels more like it's working. So this is the whole thing, again, I can't say this enough, about physics engines. There's the actual physics, and then there's what you're drawing. Mostly you want those things to match, but sometimes maybe you want to not reveal what's connecting what, or maybe you want to draw that in a different way. So there's a lot of possibilities to how you think about this. So now here's the thing. What I actually want to do is create a chain of these. So there's a bunch of different ways we could think about approaching this, but let's just build with what we have. So first of all, this idea of creating two separate particles and pushing them and then creating this constraint here, I need a kind of loop to do this. And again, I could use the built-in Matter.js composites, but I'm gonna be stubborn here and do this in my own way. So I'm gonna say var, let's think of it as going, let's actually have it go horizontally. So let's start as an x at like 20 pixels. Let's have x go all the way to the width minus 20, which is like 380. And then I'm going to go every 20 pixels. So every 20 pixels, and I'm going to comment a lot of this stuff out. I want to create a particle at x, 100. So I want to put a whole row of particles across. There we go. Now, ignore the fact that that line is drawn there. There's no, I'm going to, where is that line drawn? Let's take that out, comment that out. And that's a lot of stuff. Let's move every 40 pixels. Okay, great. So we can see here, there's a whole bunch of things. Now we're not really, there's not a lot of interplay here because they're all perfectly falling. So it's almost like there is a constraint. But let's change this now. So what do I want to do? I want to also make a constraint. And what I want is for, I want to say var p, and then I want to say var previous equals particles. Let's create a variable before the loop called previous, and it's going to be equal to null. Then, after I create that particle and in theory create the constraint, I'm going to say previous is equal to p. So what I want to do is I want to connect each particles with the previous one. That's all I want to do. So every time I go through this loop, make a particle, add it, and connect it to the previous one. However, I don't want to do that for the first one, right? So I do want to say only do this if previous exists. So only make this constraint if previous exists. So now if I were to do that, we can see, look at this. It's kind of, you can see, ooh, they're definitely connected. There's a constraint and they're all like moving along. That's cool. Now, so that's pretty good. Now here's the thing. What if I were to allow one of them to be static? So I could say, I could add an static's is a keyword in JavaScript. So what's another word I could use for static? Fixed. So I'm going to say is static fixed. So I could pass in, I could say here, like, if there is no previous, make, let's see, I'm trying to think of I just wanted the first one, this is kind of, I'm doing this, there's a nicer way to do this, I'm sure. But let's just say fixed equals false. So I'm going to pass in there, none of them are fixed. But if not previous, then fixed equals true. So I'm just going to make the first one. If there's no previous, then I want it to be fixed. So if I do this, oops, I've got an error on particle.js line number 5, which is, there needs to be a comma here because I added another property. And there we go. So you can see that first one is fixed. So what I also want to do is now I'm just going to kind of change where they are. I'm going to start this one in, I'm going to start it more in the center, and maybe I'll add more of them, but make them smaller. and do something like this. So you can see, whoa, and maybe that rest length should actually be something more like 20. And there we go. So now you can see there's what I was kind of looking to do. I created this idea of a chain that are all connected. And if I made it much longer, like if I went all the way up to 600 to add even more, right, you're going to see it's going to kind of it's going to collide with the ground and kind of stop there. That's sort of weird. Oh, you know what? It went through the bottom because it's around the bottom because the bottom doesn't extend past the screen. So anyway, this could be obviously fixed in a lot of ways, but let's just leave it at this. So this is what I was attempting to do. Now here's the thing. There's a lot of improvements that I could make for this potentially. Number one is, I've kind of got a lot of code just in the weeds here in the main program. So in the same way that I had this idea of encapsulating this idea of a Matter.js particle, a body, into an object that keeps track of its own body and other things, I could now make a chain object. And a chain is an object that keeps track of an array of particles and those constraints. Also, the way that I'm created these constraints, the same way I wrapped a body into a particle, I could wrap a constraint into a spring, so I could write my own show function, so I could draw lines between those things. That might be a bit more interesting, and so, because maybe what I actually want to do is render this in a different way. So there's a lot of possible ways, but this hopefully gives you the basic idea. Now, the thing that I want to add in the next video is how can I actually click on this and drag it around? So, the other thing that I might think about doing is, what if I were to connect them from the left to the right and then make it a kind of bridge that things fall in and kind of rest on? So that would be another thing to maybe try, play with the spring values. So many things you could try here. So hopefully this showed you how constraints work in Matter.js to give you a basic idea of what you could do. And in the next video, I'm going to add a mouse constraint. See you there. Okay. All right, so how's this going? It's almost 1 o'clock. Now I've gotten far with this, but I didn't really get time to do the challenges. Might have to come back later today. Okay, so let's see. I should at least do the mouse constraint thing. Let's do that. Let me see what improvement. I'm going to make some improvements to this. Or maybe I'll just leave it. No, let me make some improvements. Whoa. Let me do them kind of quickly here. So matter constraint. And what I'm going to do is do matter mouse. So one thing I'm going to do, I'm just going to do this I'm going to whip this together quickly. And I'm going to go here. There we go. And I am going to add a object called a chain. And I'm going to make chain. And I should probably do. Sometimes it's hard to know what to do. I was going to do the whole thing where I encapsulate the whole thing in a chain. That's going to take too long. Let's just go and add the, forget about this. Forget about this chain thing. Let's make sure this is still working. I'm kind of running out of steam a little bit here. So this works. Let's just change the parameters a little bit so it's easier to grab onto the stuff. I am going to, let me just add some drawing here. So what I'm going to do is, make these a little bit bigger. There we go. Yeah, I'm just going to do that. Okay. Okay. So I am going to, in this next brief tutorial, I'm going to add a mouse constraint so that you can grab and move things around. And I will also, that's it. Yeah, okay. Okay, so let's do that. Let me press the button on the camera. I think it works if I just come back here and press it every once in a while. It gives me another half an hour. And it is 1 o'clock. This might unfortunately be the last thing that I do in this morning, which is no longer even close to the morning. I think I could use some lunch, and I've got a lot of other things to do today if I'm going to make it back to make some more videos. But let's make this happen. Let's make this happen. Okay. All right. Okay, one more, possibly many more, but at least right now in this moment, one more Matter.js video. So this is an example that I made in the previous video, which has this nice chain of these circles and that are connected with these constraints. And what I really want to be able to do is I want to click on it. Oh, I want to interact with it. So Matter.js has built into itself something called a mouse constraint. And a mouse constraint is a constraint that's not connected between two bodies, but connected between one body and the mouse. Now, what's interesting about this is, you might want to eventually apply this to something that's not actually the mouse, but you could make an interactive system where a Kinect sensor is like doing hand tracking and you're able to move things around with your hand. All that is possible, but I'm going to show it to you with the mouse. So let's see how this works. Okay, so what I need to do is I need to go back to the Matter.js documentation, and I want to look at mouse constraint. So just as with everything we've learned right now, everything's namespaced under matter.something. So I want to work with the mouse constraint. So I want to make sure I add, I'm going to say mouse constraint equals matter.mouse constraint. So now I have that. And then I create a mouse constraint by calling the create function. So I am going to make a variable called mConstraint for mouse constraint for short, global variable. And at the end of setup, I've added all my particles, all of their constraints. I'm going to say mConstraint equals mouse constraint dot create. Now the mouse constraint gets created attached to a particular engine, right? I could have multiple physics engines within the same sketch. Pretty rare that you want to do that, but it's possible. So I'm going to put in engine, and then I'm going to, what else? Options. So once again, I'm going to make a set of options for this mouse constraint. Now, what are those options? Got to go back to this. The following properties are specified for objects created by mouse constraint.create. So these are the options that I need. A body, what is it connected to? Oh, do I really need that? No. That's not, I'm not setting that. That's going to happen by working with the mouse. Collision filter, oh, there's some sort of constraint. Mouse. I know I need this because I need to tell Matter.js about the mouse. So I'm actually backing up a second. I need to go look under mouse. So before we even do mouse constraint, what I actually need is to add a reference to mouse equals matter.mouse. So now I also need to say var mouse equals mouse.create. Now here's the complicated question. Create element, HTML element. So this is really interesting. Matter.js is a physics engine that's going to handle that in a lot of the interaction stuff behind the scenes for you. So I actually just want to say, just attach yourself to a given DOM element that's on the web page that's going to get mouse events so that Matter.js can get those mouse events. And so the thing that I want is my canvas. So how do I get the actual HTML element associated with my P5 canvas? Well, this is how. The canvas is made with create canvas. But there's no reason why I couldn't put that into a variable. Create canvas actually returns a reference to the P5 canvas object. And inside that canvas object is a property called ELT, which is actually the HTML5 canvas associated with the P5 canvas. P5 canvas is just a wrapper for the HTML5 canvas with some extra functionality. So I can say create a mouse that's attached to the P5 canvas, and then, okay, well I need to do that first. And then I would do this. Now this is a little bit confusing. It's like the property is mouse, but it's set to mouse, which is this variable. So I might just call this like my canvas. I might just for the sake of clarity, I might call that canvas mouse. So I can see those are the options. Now, maybe that's all I need. What are the chances that's all I need? Cannot read property create of undefined sketch.js line 54. Undefined. Mouse.create canvas.elt. What's undefined? Maybe mouse? Mouse equals matter.mouse. No. Yeah. What did I miss here? I'm looking in the chat to see if somebody sees it before me. Console.log mouse. Let's make sure that's not undefined. Oh, it is undefined. So what did I do wrong up here? Oh, this is capital M. There we go. Case sensitivity. You got us again. There we go. Okay. There we go. Now, what's the chance I could just click on these and have something happen? Well, this isn't doing anything. So first of all, there's a weird sort of thing that I know can happen. Oh, also I didn't add it to the world. So this is easy to forget. I need to say world.add world, M constraint. Because do I need to add the mouse to the world? I don't think so. Maybe I do. But I definitely need to add the mouse constraint to the world. So it's not doing anything if I click on them, but there is an issue. There is a very significant issue that could be at play here that I'm not so sure about. But let's fix this issue before I find the other issues. One thing you might not be aware of is that a lot of computers that you might be using have a screen attached to them that is a high density display, meaning like a Mac Retina or plenty of other examples of this, but that there's actually 4 pixels per every kind of single pixel. I mean, there's really, the pixels are the pixels, but there's more pixels per what we kind of like think are the units of measurements for the window. And in that case, the coordinates might be off. And so I can actually fix this if I go to mouse and look for pixel ratio. Okay, hold on. Where is that? Or is that in the constraint? I know there's a pixel. So let's look. Console.log canvas mouse. So it might not be in the documentation, but thanks to Liabru on Twitter who pointed this out to me, I'm going to run this again. And let's look at this. Pixel ratio. So there is a pixel ratio property to that mouse. And so I need to make sure that pixel ratio is the right number. And it's going to by default be 1. But if I'm on a high density display where the pixels are doubled, it needs to be 2. So what I can actually just do here is I can say canvas mouse.pixel ratio. I could just alter it like this. Now here's the wonderful thing. P5 actually has a function built into itself which will dynamically discover like what is the pixel ratio. So I can actually just set it equal to that function, pixel density, which will return. So this code will actually work whether it's on a high density display or not. I don't think that was the problem here, but we're certainly going to need that. Oh, it was the problem. Look at that. My mouse. So that was actually all there was. So that's great to see. So now my mouse constraints are working. So I can click on these things, and now I can't click on the fixed one. You can see there's a lot of like weird stuff going on here. So there's a couple things I want to fix about this, but so far pretty good. Number one is I really need to see what I'm doing. It would really be helpful for me to at least draw something when I click. So what I want to look at is the properties of the mouse constraint. So I want to look at the properties of the mouse constraint, because I'm going to console log mouse constraint now. So let's look at this. Look at this, body null. There is no body because I'm currently not, that property of the object is going to be associated with whichever thing that I'm clicking on. So what I want to do is say, for example, if mConstraint.body. This means if a body exists, that means I've clicked on one of them. So I just want to get var position equals mConstraint.body.position, and I want to just quickly highlight it. So I'm going to say fill, I'm going to make it green, and I'm going to draw just an ellipse there. I mean, this is totally like a wackadoodle thing to do because it makes no sense. but just to sort of see that this is working. So you can see that now, whichever one that I've clicked on gets highlighted as green. So this is a way to figure out what's being clicked on by looking at the M constraint and seeing if it actually has a body associated with it. But really what I want to do is look, and mouse has pixel ratio 2, mouse has a position there. So what I actually want to do is I want to draw a line. So I also want to look at var m equals m constraint dot mouse dot position, which I actually know is mouse x and mouse y, because P5 will give that to me, but I might as well just get it from the constraint just to be sure. And now what I want to say is I'm going to have a green outline color, and I'm going to draw a line from pos x, pos y to mx, m.x, m.y. Now we're going to have an issue here, which we'll see in a second. So, but this should show me which one I'm connected to. So I'm going to zoom in just so you can see this. I'm going to click on one of them. Now, look at that. Now it's working. It's showing what I'm doing and how I'm pulling it. But let me try to go up to the top here to show you a sort of issue. I'm going to click on the edge there. I'm going to click really high up on it. Look, it's pulling it from the center, but it's actually not pulling it from the center. So no matter what, I'm drawing my line based on the center of that body. But I didn't click on the center of that body, so the constraint is not actually attached to the center. So I need to find out that offset position. So if I go back in here, in addition to body, under constraint, point A, I think, is the offset. It could be point B. I don't really know. I think A, so I should just read the documentation, but I think A is probably, well, let's find out. So I want to go to body.constraint.point A or B is going to be that offset position. So I'm going to say var offset equals m constraint dot body dot constraint, m constraint dot constraint dot point A. Let's try that. And so now I want to draw the line from pos x plus offset dot x and pos y plus offset dot y. Okay, let's see if this fixes this for us. So I'm going to click here. Oh, something crazy has happened. So that's clearly not right. I don't know what that is. So maybe that's doing something. Point A is associated with the mouse. So let's try point B. Maybe that was the correct one. And I'm sure if I read the documentation, it explains it. But I'm just doing this through trial and error to learn how it works. Yeah, there we go. So you can see I'm now actually attached to the correct part of it based on that offset, and I can pull it around. Now, one thing that I'm not showing you here, there's an issue with using circles with a physics engine, because there's a lot of angular velocity and there's angular velocity to what these things are doing, and I can't see it, and it's sort of weird to suddenly see that line kind of rotate around the thing. So one thing just in terms of drawing, if I used an image sprite to draw there that's going to have like, eyes on it and a nose or something, I'd see this more easily. But just for sort of debugging, one thing I want to add here is just draw a line from the center to this dot r. So this, and it's already 255. So if I do this, we can see that line there. So this is going to give me, more of a sense of, yeah, you can see these things are kind of like spinning and what they're doing as they're interacting. Now, one thing is, they have collision geometry. So you could make the argument here that I actually want to ignore their collision argument. That's another thing I could go. There are actually collision filters built into Matter.js where I can tell certain things to collide with each other and other things not to collide with each other. And you could make a case maybe where I want these to be able to pass through each other in terms of how the behavior of this is working. But anyway, you can at least see here now how I'm able to use the mouse to kind of toss stuff around and interact with the elements in the canvas, which is what I wanted to demonstrate in this particular video. So thank you for watching, this Matter.js. I'm kind of not finished because you might be in the future and you might see they're like, oh my goodness, there's 5 more Matter.js tutorials after this. But right now, at the time that I'm recording it right now, this is the last one. There's plenty more aspects of Matter.js, but I will do some coding challenges to kind of make certain little mini projects with Matter.js, one of which I want to do is maybe like a Plinko machine. So you might see that appear at some point soon. But write in the comments if you have other Matter.js questions, and maybe I'll make some future video follow-ups about that. Okay, so thank you very much for watching, and I'll see you in another video. Goodbye. Okay, it is 1:10 p.m. And here are the things that I didn't get to today. I didn't get to doing the Plinko coding challenge. I didn't get to looking at texturing geometry in processing in 3D in Java. So that's something I wanted to do with a flag coding challenge. So I'm going to attempt to come back probably around 5 or 6 p.m. and do those coding challenges to try to like finish that stuff off for today. But I think it's smarter for me to take a, well, first of all, I don't have the time right now to keep going, but I can't see how long this has been going because it stopped and started so many times. But I've been here for, what did I start, around 10, 11? So a little over 2 hours. So I think I'm running out of steam. And so, but I also did not do the studio walkthrough. So it's this is what happens. I really want to do that studio walkthrough, but every time I have a free minute, I'm like, but there's more tutorials I can do. So we'll see. Maybe I can kind of do the studio walkthrough just in like 10 or 15 minutes from my phone. It's like a mobile live stream quickly before I do those coding challenges. Now, one other thing I want to mention, which is really too bad that I'm doing this at the end, because I really should have done it at the beginning, but I did pick this t-shirt, which is from Google Summer of Code 2011. I don't work for Google. I am participating in Google Summer of Code, so I do have some affiliation, but this is not, I'm not speaking for Google or Google Summer of Code here, I'm speaking for myself. But I'm going to Google Summer of Code. If you are a student, this is a program that is now open and taking student applications. I want to go Summer of Code, summerofcode.withgoogle.com. So this program works. There's a lot to this program, and I encourage you to read the website, click on how it works, go over all the FAQs, see if you're eligible. If you're not a student, you could be a mentor potentially. So I'm encouraging you to apply. I am especially encouraging you to apply if you are a member of an underrepresented group, because one thing that these programs could really use is a diversity of voices. So please, if I can help you with your application and encourage you to apply, I would love to do that. You can kind of maybe tweet me at Schiffman would be the best way. So I'm going to click here on organizations, and you can see there's a lot of open source organizations that are involved in Google Summer of Code. One of the reasons why I'm bringing this up, I would bring this up anyway, because this is a great, in case I didn't mention it, if you are accepted into Google Summer of Code, you work full-time over the summer on an open source project and are paid a stipend by Google, which I believe is $5,000. Don't quote me on that, you have to read the FAQ, but I believe that's the fee. And you can do this from anywhere in the world. You do not have to be, you can do it from anywhere. Maybe there are some countries, I don't know if they're, but anyway, read the FAQ. It's not United States specific. Okay, so I'm going down. I want to go down and find under P, processing, but it's not under P. You've got to keep going and actually go under T to find the Processing Foundation. So I'm going to click on that, and I'm going to read you. The Processing Foundation's mission is to promote software literacy and visual literacy and to make these fields accessible to diverse communities. So I'm going to click Learn More, and now there's even more you could read. Our goal is to empower people of all interests and backgrounds to learn how to program and make creative work with code, especially those who might not otherwise have access to these tools and resources. We do this by developing Processing, which is a Java-based platform, P5.js, which is a JavaScript-based platform, and Processing.py, which is actually a Python mode, part of the processing development environment. So I encourage you to read more about this here. Chat, where does that go to? That's going to take you to the forum. So if you have an idea, this is the place where you should post it to get feedback. I check this about once a day, and this is one I haven't replied to yet. This is one I haven't replied to yet either, but you can see there's a couple ideas here. And again, you can apply to other organizations. And then contact email, I don't know where that goes to. Twitter, I don't know where that goes to. I encourage you to think about applying. I assume, view ideas list. This is another place, this is an important place to go. If you go click on this view ideas list, this is a wiki page on the Processing GitHub that goes through, it has some information about Google Summer of Code. Oh, I need to update this. So it says we are in the process of applying to Google Summer of Code. So I need to update this wiki to say we're accepted and have links to it. And then you can see some past summers that we've participated in with projects. And then here you can read through and look at different things that we're thinking about. But I would like to say, you don't have to have an idea that's on this list. You could have an idea of how processing a library that you've been thinking about could be good for processing or P5 or processing.py, a feature that you think those environments could really use. So you can come up with really with your own proposal. And then the other thing I'll mention, I have mentioned this before, but we are also participating in something called Rails Girls Summer of Code. So this is this you do not have to be a student to apply to. So this you can also look into as another place to apply to work on processing and other open source projects over the summer. So I'm trying to think of what else to say. If you are accepted, you work, I think it's supposed to be full-time over the summer. I don't know what that period is exactly. And then you are also assigned a mentor, somebody who already works on processing or a related tool who then works with you over the summer to realize the goals of your project and evaluates your work. But all the administration and the application process, all of that is handled through Google. So if you have questions about eligibility and what's a valid project versus not a valid project in terms of strict rules, those are things you need to look at through Google. Okay, so I would like to take 2 or 3 minutes right now. Playing my goodbye music to answer any questions, in particular if you have a question about Google Summer of Code or anything I looked at today. I'm keeping an eye on the YouTube chat and the Slack chat. The Slack channel is for patrons. If you're interested in supporting the work that I do, you can sign up at thecodingtrain.com. It's a monthly subscription fee to participate in the Slack channel where we discuss topic ideas and answer questions. But everyone is always available to watch this stuff for free or whatever through whatever magical YouTube advertising thing that happens as well. Room tour. Boy, you guys really want that room tour. Okay, I'm going to prioritize that. I'm sorry, if you ask me a message, a direct message, I'm not going to see those right now because I have to click around. I just have a view of the live channel right now. Sorry, Lost JHP. I will look at it and ask you answer afterwards. So Darshan asks, I have lack of knowledge. Can I participate in Google Summer of Code? So this is a very good question. You do not need to be an expert. I encourage you to apply to Google Summer of Code, especially even as a beginner. One of the things we like to do at the Processing Foundation is bring in new people to open source. And you can't do that by only getting experts who have been working in whatever for many, many years. So to have new voices, to have new energy, beginners need to feel that they're welcome. So I think it really then, though, if you're a beginner, it's really about crafting a proposal around something that's reasonable. So maybe you don't want to apply to revamp like a very complex part of the processing IDE, but making a library that adds a sort of like mathematical algorithm that you know something about, but maybe you're not as experienced of a programmer. A mentor could help you realize that. So I think it's really about crafting the proposal with your skill set. I'm looking for more questions. I actually don't see any more questions. I'm seeing somebody say that the question was, I only see the last 2 comments. Is there a way to use keyboard with Matter? Yes, you absolutely can use the keyboard with Matter, but you're probably going to have to, sort of an it depends type of thing, because you can get, the keyboard events are going to come through P5.js, and then you're going to call various functions associated with the physics library based on those keys that are implemented. Processing, yes. Where should I go if I want to port processing to another language? Is it open source? It's absolutely open source. Everything about processing is at github.com/processing. This is our Processing Foundation GitHub page. There's a repository for P5 website, the web editor, processing Android. Let me pause for a second. Oh, it ended. Processing documentation. So you can see there's a lot of repositories. It's all open source. Michelle in the chat asks, you should add physics to processing. So physics is not built into processing. However, there are many libraries that are processing libraries that you can do with physics. And I actually, the reason why I looked at Matter.js today is because I already have a whole set of tutorials about working with Box2D and toxic libs, which reminds me I should do an updated toxic libs tutorial because you need to get the library in a slightly different way probably than I presented. Somebody help me remember that. Maybe I can just do that in a couple minutes later today. Okay, so thank you everybody. It is 1:20 p.m. I believe this has been a 2.5-hour live stream, though it's hard to say because it kept crashing. Thank you again for your support, for watching, for your kind words, your feedback, for your critical, for your constructive feedback about things that I could do better. I'm always happy to hear. Share with me things that you've made. And do not forget to make a self-avoiding random walk in the future. So I would like to see Manny, I think, is working on some ideas around improving my topic suggestion system where I can get a sense of what the audience is really interested in through more upvote voting. So if you really want me to do that self-avoiding walk, I'm absolutely happy to do it. Go find the GitHub issue on the Rainbow Topics repo and put a thumbs up on it. And that will move it to the top right now. Okay, see you guys, and I'll be back this evening. I'm excited for that. I'll definitely be back. Even if all I do is the room tour, I'll be back. And at some point, I will do those other things on my list. It's just a matter of when I get to it. Okay, I gotta turn this off now. How do I do that? Ooh. I just pressed the button over here. It's always this weird thing. To turn it off. Someday, you know what? This YouTube TV thing I'm kind of interested in. I don't know if you guys heard about this. Is this going to help what I'm doing here and make it available in a different way for other people? Do I need to be more professional in my production values? Okay, stay tuned. I'm hopefully going to launch the Coding Train merchandise store next week. And maybe if you have some ideas for some little contests or something I could run to give away some stuff, I would love to give away some stuff as well. So if you have any ideas about that, send me your ideas on Twitter. Okay. And I'm going to, okay, one last question, because Sandeep posted it twice, although I shouldn't reward the posting the question over and over again. In your Mosaic challenge, how to do with RGB values, at least a hint. Boy, and I read that question. So I have a coding challenge where I make a photo mosaic just based on grayscale values. With RGB values, I might do something of looking at, one way I could do it is look at the average value, the average color of a particular small image tile, and then maybe look at the distance between that color and the, so instead of having specific images for certain grayscale values, I could just have a pixel and try to find the image that's color most closely matches it. But that's only a small little inkling of a way of doing this. There's probably a lot of more sophisticated ways of really thinking about the, not just the average color of your tile, but kind of where the color is and that sort of thing. But okay, so I'm going to go and I will, so if WWTFF blah, 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 blah asks, what is the time commitment for Google Summer of Code? Read their FAQ on the Google Summer of Code website. It goes through that in detail. My sense is that they would like it to be kind of like a full-time activity. That doesn't mean that you probably couldn't do the Google Summer of Code work, I think in my eyes, in off hours, but really you should read their FAQ. There's very strict and specific rules about that. I really shouldn't answer these questions because I'm not a representative of Google. And so you should, there's actually a discussion group list and a place where you can ask those questions about Google in terms of what those eligibility requirements are. C-Manny asks, when is the world tour? I don't know, I would love to go on a world tour. I don't know what that means. Coding Train Live, there is a possibility that a Coding Train Live might happen in a certain next fall because there's a thing that might happen that I could do something from. With a live, I would love to do something with a live studio audience. I know that there are people who do this. There's stand-up maths, which is something I think in the UK about math stuff. They do this. I don't know if I'd be very good at that, but anyway, someday. And Seb Lee Delisle is an artist also in the UK who does some kind of live coding stuff in person. And actually, I do have access now with my subscribers to YouTube Studios, which is there's one in New York, there's one in London, there's one in California, there's a bunch, and they have I think a theater there. So maybe I should think about trying to do that. So I could do a Coding Train. If someone wants to help me figure this out or knows about YouTube Studios, somebody works at YouTube can get in touch with me. I would love, yeah, so I might be in London over the summer, in which case I would maybe try to do something there. people are asking if that. I don't know if that's really happening, but so I would love to do. I'm open to ideas. Would love to do something like that. I think that would be a lot of fun. I especially love to do it with like guests. Have other people come, like a kind of an evening of different people doing coding stuff that's not just me in particular. So let's think about that coding train community. Choo choo. We'll all take the train. You know, there's this thing by the way called Indie Train Game Jam. Train Jam. Hashtag. Let's look. Twitter.com. I'm going to go to hashtag train jam, I think. Look at this. It's already 1:30. I'm still here. Yeah, there's like a train jam. Let's look at the, which is like people making games on trains. And I feel like, what a wonderful idea. I don't know. That's all I have to say about that. The camera went off. That means goodbye. I'm out. Mic drop. See you tomorrow. Oh, no, tonight, later, whatever. It might be tomorrow your time.